APV shutoff valve. Hold the standby APV shutoff valve open until the desired pressure level is obtained in the power APV. Close the standby APV shutoff valve. Close the charge APV valves. Now that we've set the air pressure in the power APV, let's see how we set the air pressure in the standby APV. This pressure level is normally held at maximum system pressure, or at least twice the pressure which the power APV will operate, whichever is smaller. To increase the pressure, close the charge APV valve. Open the standby APV shutoff valve. Open the air compressor shutoff valve and start the air compressor and run it until the desired pressure level is obtained. Stop the air compressor. Close the standby APV shutoff valve. Close the air compressor shutoff valve. The tensioner system is now ready to activate. By opening the activate tensioner valve, the tensioner will become active. The method by which this is achieved is affected by the application or operation to be performed. In other words, tensioning the riser pipe, lowering the riser pipe, or raising the riser pipe. Riser pipe tensioning is accomplished by first checking the reeving of the wire line through the tensioner to the top of the riser pipe slip joint. Check the tensioner's cable anchor and ensure that the wire rope wraps around the snubbing ring at least 2 or more full contact wraps. Ensure that the cable is of sufficient length to have at least 60 feet of free length beyond the cable anchor. Check the wire line end connections and open the activate tension valve. The support lines from the tensioner to the riser should be of the correct length. The correct length will leave the tensioner stroking about a predetermined stroke position. The idea is to position the cylinder rod to account for vessel heave, tide, and changes in the vessel ballasting so that the tensioner stroke does not bottom out. The riser tensioner can be effectively used to lower the riser pipe to the ocean floor or the subsea structure. This operation applies to the last 10 to 30 feet prior to actual contact. This is one method of doing it. Set the air pressure in the power APV to a level giving total tension equal to approximately 110% of the suspended riser pipe weight, but never more than the system capacity. Lower the riser pipe by the drawworks or other normal procedure to within 10 to 30 feet of contact. Next, after uncoupling and suspending the slip joint from its normal mount, activate the tensioners by opening the activate tensioner valve slowly. The tensioner should now be fully extended. Secure the riser pipe support lines in place. Clamp the cable anchor on the riser tensioner and secure the support lines to the top of the riser pipe. Slowly lower the riser by the drawworks until the riser tensioners are fully supporting the riser pipe's weight. Slowly bleed air pressure from the tensioner system by opening the vent APV valves. As the tension decreases, the riser pipe should slowly approach, then contact the subsea structure. Continue to decrease the air pressure until all relative motion between the riser pipe and the sea floor has ceased, and then close all vent valves. Complete the normal hookup of the riser pipe and the subsea structure. Adjust the pressure in the power APV to provide desired operating tension level. The riser tensioner can be effectively used to raise the riser clear of the subsea structure by adjusting the tension level of the normally connected and operating tensioner system to at least 110% of the suspended riser pipe's weight, but never more than the system capacity. Disconnect the riser pipe from the subsea structure. When the riser pipe is disconnected, the tensioners will fully extend in a somewhat slow manner and raise the riser pipe clear of the subsea structure. Its retrieval is then handled in a normal manner. After supporting the riser pipe from the drawworks, relax the tensioner by closing the activate tensioner valve and opening the vent tensioner valve. The complete shutdown procedure for the system is as follows. Push the compressor stop button on the control panel. Close the compressor shutoff valve on the control panel. Close the activate tensioner valves on the control panel. Turn off the air regulator on the control panel. Close the air shutoff valve on each air oil reservoir. Open the vent tensioner valves. Open the vent APV valves and open the charge APV valves. Open the standby APV shutoff and vent air from the air oil reservoir by the relief valve lift lever. Now let's take another self-check quiz. Turn to page 4 in your workbook. When you hear the tone, stop the playback unit and begin answering the questions. Ready to check your answers? Number 1 is B, relief valve. Number 2 is true. Number 3 is B, 40 to 50 psi. Number 4 is A, twice the pressure. 5 is true. Number 6 is D, open vent APV valves. Number 7 is true. And 8 is true. Now we're going to take a look at the guideline tensioners. And in case you've forgotten, the purpose of the guideline tensioners is to keep slack out of the BOP stack guidelines. This prevents their fouling the riser pipe and the BOP stack. The guidelines are used for guiding subsea equipment down or up between the rig and the sea floor. The guideline tensioners are similar in design and operation to the riser tensioners. They are different in that they are smaller, both physically and in force. The 16,000-pound size unit has a 10-foot stroke and a 40-foot line travel. The 14,000-pound unit has a 7.5-foot stroke and a 30-foot line travel. High-pressure air operates directly against the cylinder piston. Use of an air oil accumulator is not necessary for guideline tensioners, however, because they operate at low tension loads the majority of the time. Hence, the packing wear is considerably less severe than is the case of the riser tensioners. Guideline tensioners use less air volume than riser tensioners due to the smaller cylinder volume which the air must fill. The dead end of the cable is not anchored to the tensioner but leads out to a winch. This allows the guide base to be raised and lowered to the ocean floor. A guideline tensioner system is composed of 4 subsystem components: the tensioners, the air pressure vessels, the high pressure air source, and the control panel. Proper inter-subsystem connection is required for a successfully applied tensioner system. The guideline tensioners are basically pneumatic hydraulic cylinders with a 2-sheave block on the rod end and a 3-sheave block on the fixed end. There are several models, and each model is determined by the original installation design. The tensioner assembly is marked with its own model number, which indicates mounting position, cylinder bore, cylinder stroke, stroke position, switches, and wireline size. There are several controls located on the tensioner in addition to those on the control panel. The blind end piping assembly, located at the blind end of the cylinder, contains 2 ball valves on the 14,000-pound tensioners and 2 ball valves and a relief valve on the 16,000-pound tensioners. One is the air shutoff valve, which enables the operator to isolate an individual tensioner from the high-pressure air line. The other is an air vent valve for venting air pressure from an individual tensioner. An oil shutoff valve is located on the air oil reservoir. It is used to shut off oil flow to the cylinder. It may be used to lock the tensioner in a retracted position. By the proper application of air pressure through the air shutoff valve and closing of the oil shutoff valve, the cylinder may be locked in any position between retracted and fully extended. The normal operating position of the oil shutoff valve is fully open. A flow speed control orifice is located between the air oil reservoir and the cylinder, which limits cylinder extension speed and provides controlled damping. An air shutoff valve is provided on the air oil reservoir. It is a local control for that individual tensioner. Normally, it remains in the open position. The air oil reservoir has a drain for emptying oil from it. Its normal position is closed. Also on the air oil reservoir is a relief valve. This prevents the air pressure in the reservoir from exceeding a preset safe value. This setting is normally 95 to 120 psi and should always be maintained at that range. As in the riser tensioner systems, the guideline tensioners have rupture discs installed to ensure against exceeding the safe operating pressure of the air oil reservoir. The rupture disc must be intact during operations. Included in the system is an oil level sight gauge. This sight gauge indicates the oil level in the air oil reservoir. The gauge at the reservoir's bottom indicates the correct oil level when the cylinder is fully retracted. Next are the stroke position switches. These magnetic reed switches on the stroke position indicator are used to indicate the incremental position of the cylinder rod. They are normally mounted on only one tensioner of each pair. Next are the APVs, which are similar to those used in the riser tensioner systems. All tensioner systems operate with APVs as an integral part of the system. The volume of these vessels is specifically designed for the tensioner to which it is applied. They must not be replaced by APVs of different size. The power APV normally operates up to 2200 psi with a maximum working pressure rating of 2400 psi. Quantities of APVs used in guideline systems may vary from rig to rig. Some systems may or may not contain a standby APV. The guideline tensioner control panel is designed for centralized operation. A single operator can perform all the normal control functions from one location. Adjustments may be made while the system is under dynamic or static operation. The system's panel is similar to the riser tensioner panel with only a few minor changes. It normally receives its high-pressure air from the air compressor air dryer unit or the standby APV from the riser tensioner panel. The controls are as follows. The air regulator valve regulates the air pressure in the air oil reservoir. It is normally set at 40 to 50 psi when the tensioner cylinder rod is fully retracted. Next is the charge APV valve. This valve controls air from the high-pressure air source to bleed into the power APV. Before opening the valve, be sure that the air source is active. The air compressor is operating or the standby source is connected. During normal operation, they are closed. The activate tensioner valves separate the tensioners from the power APV. During normal operations, they are open. There are three types of pressure and tension gauges. There is a low-pressure gauge, which indicates the pressure level in the air oil reservoir system. A high-pressure gauge, which indicates the pressure level in the standby APV or the pressure level in the high-pressure air source. And one or more high-pressure gauges, depending upon the system, which indicate the tension level in the tensioners. These gauges read directly in pounds of tension and indicate the tension per tensioner. The total tension obtained is the sum of all tensioners in operation. Next is the stroke position indicator, which is similar to the riser tensioner stroke position indicator. It has panel lights which indicate the incremental position of the tensioner cylinder. There is a high-pressure air shutoff valve which isolates the system from the high-pressure air source. When charging the system with high-pressure air, this valve must be open. It is used in conjunction with the charge APV valve. The air oil reservoir, which is partially filled with oil, has a 40 to 50 psi air charge from rig air and is piped into the rod end cavity of the cylinder. This arrangement provides system damping, continuous lubrication, and safety control over stroke velocity in the event of a wireline failure. To operate the guideline tensioner system, upon initial startup, or if it has been idle for some time, first ensure that all piping is properly connected and oil levels are correct. Then open all three gauge shutoff valves behind the panel. Open the air vent valve at the blind end of the tensioner. Check the air filter and drain at the control panel. Open the air shutoff valve at the air oil reservoir. Pressurize the air oil reservoir with rig air to 40 to 50 psi. Set the regulator. Open the oil shutoff valve between the tensioner and the air oil reservoir. The tensioner should be fully retracted. Open the high-pressure air shutoff valve at the blind end of the tensioner. Open all valves on the control panel. Start the air compressor air dryer unit, bringing in high-pressure air. Close the activate tensioner valves on the control panel. Close the vent APV valves on the control panel. Close the vent tensioner valves on the panel. Open the APV shutoff valve at the APV. Make certain the APV drain valve is closed. Allow pressure to build up in the APV to 150 to 200 psi. Vent air at the control panel by opening activate tensioner valves and vent tensioner valves. A few seconds will suffice to ensure clean and clear air. Close the vent valves at the panel. Air will now be directed to the tensioner and vent at the blind end vent valve. After a few seconds, close the blind end vent valve and the activate tensioner valve. Pressure is now building up in the APV and is blocked from the tensioner. When the APV is charged to the desired pressure level, close the high-pressure air shutoff valve on the control panel. Inspect all shivs to ensure that they are well lubricated and free turning. After you are satisfied that the system has been checked out thoroughly, you are now ready to activate the tensioner. Charge the power APV to the desired pressure level. Open the activate tensioner valves. The tensioner is now operational. Only occasional recharging of the APV by the compressor is required once the operating pressure is attained. The high-pressure air shutoff valve on the panel remains closed most of the time. If the riser tensioner system is used as a high-pressure air source, the compressor or the standby APV may be used. The operator will soon become aware of the exact amount of tension the system will require. Adjustments of the guideline tensioner to keep the cylinder stroking about its midpoint may be required if tide levels or vessel ballasting cause the stroking to approach one end of the cylinder or the other. This is normally accomplished by either letting out line or taking in line on the winch. For guideline tensioner system shutdown procedures, see your service manual. Also, check your service manual for drawings and procedures on system disassembly. This assembly operation is being performed in one of Rucker's hydraulic equipment supplier plants. Let's take a brief look as the components are assembled. You can perform the same operation aboard an offshore drilling vessel. Now we'll briefly cover troubleshooting. While we can't cover all of the malfunctions you may someday encounter, here are a few that you might be called on to investigate. Most malfunctions usually involve air or oil leaks in the system that cause its load-carrying capability to deteriorate. If there is interior leakage in the cylinder, it is often detected by high-pressure fluid leaking past the piston assembly into the low-pressure reservoir assembly. Foam is usually generated when this occurs, and it backs up into the low-pressure piping system. Looking much like shaving cream, the foam comes out of the low-pressure regulator on the control panel. This malfunction is usually caused by fluid seeping past the piston because of scoring or worn spots on the piston ring. Leakage through valving, joints, or pinholes in the piping is usually indicated by a loss in pressure. While you are looking for the possible leaks, don't forget that the pressure change might be due to the rig changing positions by ballasting up or down, or because of a 6-foot or more tide. Leaks in the piping can often be found by using a soap solution on the joints. It will bubble if the area is not leak-free. One last troubleshooting tip. If the ruptured disc on the air oil reservoir blows out repeatedly, there are 3 common causes of failure to look for. 1, the oil level is too high. 2, the initial air pressure in the reservoir is too high. Or 3, the relief valve may be malfunctioning.